Hi everyone. Today's topic is the first of our probability topics. So we are going to talk about the difference between permutations and combinations. And so kind of our overarching question today or topic is how many possible outcomes are there? And so we're talking about math problems where you might be given a problem that says, hey, you have 5 shirts, 10 pairs of pants, and 6 pairs of shoes. How many possible outfits can you make? And all types of problems like that. So we're going to start with first the simplest of these topics, and that's the fundamental counting principle. It sounds really difficult and complicated, but it's really simple, and it's just the idea of how many outcomes you have for one event, how many you have for the other, and then how many you would have for both. So if one event has, let's say, n outcomes, let's just represent some number, and a different event has n number of outcomes, well then the amount of both is just the first one times the second. So this is really just multiplication. And the next few problems are going to be as simple as that. Okay, so first example, if I have an ice cream shop with 3 cone sizes, 15 flavors, and 8 toppings, how many one flavor, one topping options do I have? And so I'm going to take the number of possibilities for the first event, if you will, or sizes, so that's 3 cone sizes. And then if I have 15 flavors, then that's how many outcomes I have for the next, so I'm going to multiply. And then if I have 8 toppings, I'm going to multiply by 8 possible toppings. And if I multiply all 3 numbers together, I get 360 possible ice cream cones, and so I can just use that as my unit. Ice cream cones. The important part to notice here is that I said how many one flavor, one topping options do we have. So it's just one of each. All right, to the next example, if we are taking a science test and there's 12 questions, they're all true or false, how many ways can I answer that test? So how many possible different versions of answers could I have? So you have to think about this as each individual question. So question 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And for each one is an event. You have 2 possible outcomes or answers. So 2 times 2 times 2, and that's for every single question. So I have to multiply that 12 times. So 2, that should be a 2 and a 2. 2 times itself 12 times is 2 to the 12th, and that's going to give me 4,096. So that's how many ways you could possibly answer that test. That's a lot. All right, so that's our fundamental counting principle. It's really simple, just multiplying all the outcomes together to get the total. Next, I want to talk about factorials. We're going to use these in the formulas coming up next. So we need to know what is a factorial. If you haven't seen one before, it's a number, so we're just going to use n, and then an exclamation point. All this is a shorthand for a calculation that we can do in our calculator. So what a factorial means is it's the multiplication or the product of a number times all of the numbers less than it all the way to 1. So this would be 6 times 5 times 4 times 3 times 2 times 1. And you can go in your calculator and do this multiplication. You also may have a button for this. So if I zoom in a little bit, you might see my calculator has a factorial button that I am not finding right at this moment. I know I have it. Right here. So see, it says exclamation point. So if I want 6 factorial, 6 exclamation point, 720. So basically what my calculator did is it multiplied all of these numbers together for me. So 6 factorial is 720. All right, let's do a smaller one, 3 times 2 times 1. This one's easy. This is just 3 times 2. That's 6 times 1, and that's just 6 still. And then last one, I'm not going to write all the steps out for it, but I'm going to give you a second and try to calculate 12 factorial. Now's a great time to pause the video, see if you can do this by yourself. All right, and if you tried that, you should get 479,001,600. And again, your calculator can do that for you if you have that button. Otherwise, you would just do 12 times 11 times 10 and so on, all the way to 1. Okay, so we've got our fundamental counting principle. We've got our factorials down. We are now going to get into the difference of our permutations and combinations. So I'm going to change my page here, and we are going to talk about permutations first. So this is if we want to know how many arrangements we can make when order matters. Let me clear this up a little. So we have a formula to figure out how many arrangements we can make when order matters, and that's our permutation formula. This is if we were creating words or certain lineups of people. Every different arrangement is going to be different depending on the order. So if the order matters, then it's a permutation. We'll get into some examples, and it may be a little more clear when you see real examples. Okay, so our formula for our permutations is going to be NPR. I like to say NPICR, but let's write a formula. So it's n factorial divided by, and then we've got n minus r factorial. Okay, so our n value, this is the total number of objects, so it's like whatever we're picking from. This is our total number. And then our r, let me write in, my n is green. My r is how many I'm picking for each arrangement. So this is how many in each arrangement. So let's say I had 20 pencils and I want to arrange them in different orders, but I'm only picking 5 at a time. So my n value would be how many total, and then r would be 5. Just a note, if your n and r are the same, so let's say I have 5 pairs of pants and I want to order them in all different ways, but I'm using all 5, then you just do n factorial, 5 factorial. All right, so let's get into some examples and see what does it mean to be a permutation, and what are we really answering here. So first example, how many ways can you arrange the letters in this word dinosaur? So I'm going to take all, looks like 8 letters, and I'm going to order them in a bunch of different ways, and I'm going to use all 8 every time. So my n value is going to be 8. I've got 8 letters, and my r is also 8. I'm using all 8 every time. The reason order matters here is because if I were to, let's say, switch the u and the r, that would make a completely different word. And so that means that arrangement is a different arrangement. The order matters. It creates a new arrangement. So we're going to use our n and r values, so 8p8, and this is the example where we can use the shortcut. We're just going to do n factorial, so 8 factorial, and that's going to give me 40,320, and when we're arranging letters, that makes words. So we have this many possible words just by arranging 8 letters. Pretty crazy. All right, another example. How many ways can you take 7 students and have them finish in first, second, and third place? Now, if you have 7 students, only 3 can be included here, first, second, and third. So that means our n value, our total, is 7. But the r value, how many we're choosing every time for the first, second, third place, that's 3 students. So this is 7 pick 3. Okay, so we're going to use that formula with 7 and 3. So the n value, that's 7 factorial all over, and then 7 minus 3 factorial. Okay, so this is going to tell us how many ways 7 kids can finish in first, second, and third. All right, so on the top, I'm going to show you how to simplify this if you haven't seen this before. So this is 7 times 6 times 5 times 4 all the way to 1. And then 7 times 3, remember you do parentheses first, that's 4 factorial. And then remember, all of these are multiplied and all of these are multiplied. So I can cancel anything that I see in the numerator and the denominator because there is multiplication between each term. So the 4s, 3s, 2s, and 1s. So the only math I have to do, in case you don't have the factorial button in your calculator, is 7 times 6 times 5. That'll give me 210 ways. that 7 kids can finish in first, second, and third. All right, and then last thing for permutation is what if there's repetition? So what that means is what if, let's say we're using letters in a word, but some of those letters are repeated. We have to account for that repetition, and so I'll show you how to do that. So this time we're using the word disappear. We have 9 letters here, but some of the letters repeat, so let's see what those are. So we have an A, and then we have a P. If you hear that, that's Phoebe running across the apartment. All right, so we have 2 letters that repeat. We have 2 A's and we have 2 P's. So we're going to account for those in a moment. Let's start our formula. So the N value is 9. We have 9 letters. And we are choosing 9 every time. So this is just going to be 9 factorial. So 9 factorial. But then I have repeats. So what you're going to do is you're going to divide by the number factorial that each letter is repeated. So A is repeated twice, that's 2 factorial, and P is repeated twice, so it's another 2 factorial. Another example is like if I had a letter repeat 3 times, I would write 3 factorial. Okay, so you're dividing by those repetitions to make sure you account for different arrangements that are exactly the same. We don't want to count too many. Be careful here, this is 9 factorial on the top. This is not 4 factorial. This is 2 factorial times 2 factorial. Make sure you don't mix that up. So 9 factorial, 9 times 8 times 7, all the way to 1. And then down here it's 2 times 1, 2 times 1, right? So we can cancel these. And then if you want, you can cancel this and turn it to a 2. So if I do all this multiplication, I get 90,720. And that's how many words we can make or arrangements with those 9 letters, with the repetition. Okay, so that's permutations for us. And then the last thing we're going to do is our combinations. So this is when we're making different arrangements, but the order does not matter. So when we change the order of the objects, it's still the same arrangement. So it doesn't count for like a new outcome or arrangement. So combinations. This formula is very similar. We've got our n and our r value, but this time we have n factorial on the top, divided by, and then we have r factorial times n minus r factorial. So we have added in this product right here, r factorial, and that again is to account for repetition, because when order doesn't matter, you have less outcomes. So you'll notice that permutations for a certain problem are going to be more than combinations. There's usually more permutations than combinations. All right, same as before, n is the total, and r is the number chosen every time for each arrangement. So this I like to say n choose r. The other one was n pick r. Another shortcut, if you have the n and r value that are the same, that means that your amount of combinations is just 1. So if you have 5 people and you want to know how many ways you can group them into 5, well, it's 1. You can only group 5 people one way. Okay, so let's get into some examples. Our first one, how many ways to choose project groups of 5 from a class of 16? So our total to pick from is 16, but we're only choosing 5 every time. We want to know how many ways could I pick a group of 5 from this many people? So my r is 5. So if I want to write this formula, this is 16 factorial all over 5 factorial times 16 minus 5 factorial. So let me simplify this a little just to show you the math that's going on here. So this is 16 factorial over 5 factorial times, and then if I do this multiplication, or I'm sorry, division, this is 11 factorial. Make sure you do not multiply the 5 and the 11. Do these separately. This is 5 factorial, whatever number you get, times, and then whatever number you get. Okay? Once you divide, you get 4,368. So that's how many groups you can make of 5. Let me just show you real quick why the order doesn't matter in a group. Let's say you have, I don't know, John, Sally, Tiana, Joe, and Bob. That's 5 people, right? It doesn't matter what order you put these people in, it's still the same group of 5. So that's why this is a combination, not a permutation. All right, second example. How many ways to choose 4 candy bars to buy from a store that offers 30? So again, think about if you're buying 4 candy bars. It doesn't matter which order you pick them in, you're still walking out of the store with the 4 candy bars. So these are just groups. Order does not matter. So I don't know if you guys just heard that, but there was a huge crash outside. Oh my goodness. My N value is, it's the perks of living in the city, guys. N value is 30, it's my total. And then my R value is 4. Okay? So again, using my formula, I've got 30 factorial divided by, and then I've got 4 factorial, 30 minus 4. So again, this is just a plug and chug. You're taking those numbers, plugging it into the formula. Once I calculate this, you get 27,405 different ways. All right, so just to finish off, this is a great thing to take a screenshot of or just pause. I have given you some examples of key words that you'll see, because sometimes the hard part about these problems is just deciding, am I doing a permutation problem or am I doing a combination problem? So if you see these words, this tells you you're working on permutations, and if you see words like this, you're working on a combination. Thanks so much for watching, guys. We will have more probability videos in the future. I hope you guys have a great day. Bye-bye.